Okay. Good morning, Peru. Good afternoon in Norway. Welcome to the JConf Peru 2020. We are with Rustam. Um, Rustam, sorry, give me a second. Rustam
Welcome, everyone.
Mehmandarov lives and works in Oslo, Norway, working as a chief engineer and consultant specializing in Java platform, a competency network coordinator at work. Hello, Rustam. Thank you for your participation
Thank you
in
for
our
having me.
conference.
It's great to be here. It's really fun to be here. I think it's my first time in Peru. I mean, even though it's virtual, but it's like I guess it still counts, right?
Yeah. Okay.
All right.
Can you start?
Yeah, I think should I just go ahead and start then?
Yes.
Yeah, I think I will. Okay. Yes. All right then. Again, thank you all for being here. It's really great to be able to join the JCOM Peru, even remotely. I mean, right now it's morning for you. It's quite well. It's getting after kind of late into afternoon here in Oslo, but it's still great to be able to join you kind of on the other side of the fiber cable and everything. So I have a talk today, and I will be talking about something which is, well, I mean, it's probably, let's be honest, it's probably not the most kind of exciting thing that you can be doing in with code and with Java especially. It's building data pipelines, and I want to, but to make it a bit more exciting and to be able uh, to give you some kind of introduction to this thing, I would like to tell you a story, and this story is, it actually has like um, two agendas in a way. I mean, I have two aims for this thing. It's one of them is actually I would like to explain what this the framework that I've been using and how you can use it and what you can do with it, and things, the regular things. But then there is another kind of a little bit more hidden agenda for this thing, and that is to be able to inspire people watching this talk to actually try to solve their problems. I mean, the things that they kind of encounter, things that you encounter during your like daily life, and things that kind of bother you a little bit. I would like to encourage you to use your code, or to use your skills as a programmer, as a developer, to solve this kind of thing. So let's go with this talk, and let's go ahead and see where it will get us. So I usually like to start this talk with a short demo. So let's see how that works, because it means that I'll need to use speakers on my machine. So we'll see how that works. Okay. Hey Google, what's the bike availability next to my house right now? Let's see.
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
It worked. Okay, so I hope you heard the voice, and basically it was the assistant voice telling me about the bike availability right next to my house. And the bicycles I'm talking about is this kind of public service bicycles. I'll show you in a second what kind of bicycles I'm talking about. But I would like to kind of rewind the story and the tape a little bit back in history, in time, and to go a little bit back and to explain you what that thing that I showed you actually is about. So the thing it's about is the bicycles like this. So this is, I'm pretty sure that you've seen those bicycles in wherever you live, or other places. I mean, I've seen those all over the place. So the blue ones that you see on the little bit darker image on the right side are from Oslo, from Oslo, Norway, where I live. And the ones on the other side, the red ones, the little bit lighter picture, that's I think that's from Belgium. So when I was at Devox, Belgium, I took this picture, and I took the similar pictures because I was doing this talk different places. So I did the same thing in Madrid. I did the same thing. I found the same thing in San Francisco. So you'll see them pretty much everywhere, I would guess. So the thing is that this is the idea is that it's a public service kind of thing organized by the city or whatever kind of setup you have locally, and that would be the thing that you buy a membership for this thing for a I don't know, month, a year, or whatever works in your city. In Oslo, I think it's for this season. So basically, it's a year, more or less, minus a few months. And then you can just pick up a bike and use this thing to log in to identify yourself. Whatever you use, app, it can be a card, it can be like different things, and then you can pick up your bicycle and you can bike wherever you want. And whenever you see this locks like this, you just put them back into this lock and you're done, right? So basically, you have a bicycle available all the time inside within the city for a very cheap amount of money. I mean, it's nearly, well, almost for free in Oslo. I mean, it's cost a few. What's that? A few, I think it's like 50 bucks or something like that. I don't remember exactly the price right now, but it's quite cheap, right? For a year. But that's in theory, because I mean, the theory is that you can actually get this bicycle. It's really nice weather and you just pick it up and it's always available. You can find it. You just go wherever you want or wherever you're planning to go, and then you can just lock it there. So this is the marketing pictures that are usually they're using here. For instance, this is the Norwegian bicycles, the Oslo bicycles, and this is the same thing, right? It's another thing. It's very nice weather. It's sunny. It's warm, and you just pick your bicycle, you go wherever, and you just enjoy the ride. The thing is that it's Norway, right? So it's already getting pretty cold. So now we're getting close to 0 Celsius. It's not 0 yet. It's somewhere between 0 and 10, going a little bit back and forth. But it's getting pretty cold. So very soon it will be more like this. But then it still works. I mean, they still have some kind of pilot projects where you can actually get the bicycles and even bicycle in weathers like this. So that's fine. But the problem is that when you get this thing and the spring comes and everybody is super motivated to get the bicycle and bike around, you buy a membership. And then you're looking forward to do all this, all these beautiful pictures that you've seen and everything like that. And by the time you get to actually to go somewhere and you need to go somewhere, you kind of, oh yeah, I have this membership thing. I'll go and I'll find all the bicycles like this. So this is a picture I took of this bike thing right next to my work. So I kind of pass it at least twice a day. I go to work a little bit more often than twice a year. So twice a day. And then, you expect it to be like this. But in reality, it's a bit more like this. So this is exactly the same stop from just a different perspective. And bicycles are gone. So all of them are gone. And this is kind of the same thing again with the same perspective as you've seen earlier. So you go from, you expect to see something like that, you end up seeing something more like this. And that sucks because, well, now you've been planning to go somewhere, you've been expecting to bike there, and you thought that it will take shorter amount of time, and now there are no bicycles available. And then you get a little bit sad. So then you get a little bit disappointed, and you're like, well, I was kind of looking forward to this. I did not bring my own bicycle, and I paid for this thing, and it's not working. And then you kind of, this is the part where I kind of try to tell you people as well, see if you can solve the problems that you experience with the code. So my reaction was, well, first was getting a little bit sad and a little bit disappointed and like, well, I need to go somewhere and I will be late if I don't. And then it happened to me once, twice, a few times. And then I got a little bit, I was like, okay, fine, let's do something about it. I can write code. I can, I do get paid basically for writing code and developing systems on my daily kind of 8 to 4 or 9 to 5 or whatever work during the day. So maybe I can use the skills for solving my own problems in the evenings as well. So that's how my pet project started. And the pet project was kind of, the idea was first to this was kind of the train of thought that I had. So the first one was like, okay, well, the thing that we talked about, right? You have you try to bike somewhere, there are no bicycles. Well, that sucks. Okay, what can we do about that? Where can I find a bicycle? Well, I don't really know, because, well, there is an app and there is a web page and everything, and it will show me the availability real time, which is nice. But by the time I get from my place to that bike stop, which is kind of 2 minutes away, I think the closest is just 2 minutes walk, or maybe even less from my place. The problem is that within those 2 minutes, let's say it's 2 minutes, within those 2 minutes, somebody else will pick up the last bicycle, and all of them will be gone. So by the time I get there, there will be nothing. So that kind of sucks. So can I use an app? Well, I mean, no, because of exactly the same reason. It's real-time data. I have no idea about like the trends or availability patterns or anything like that. I just have real-time data. That doesn't work. Okay, fine. Can I use a public API? Well, maybe. The problem is, again, the same thing. This the web page and the app are using that public API that provides me real-time data of whatever is available right now. So I cannot use it directly, but maybe I can use something. I can do something about it. So I guess I can collect historical data and I can put it into some kind of something, database or whatever, and then I can have a historical like trends and everything, so I can actually do a lot of things with it. Yeah, I can do that. Okay, how can I do that? So that was the next question. So next question was like, okay, what do I do in my regular job? I do a lot of kind of enterprise software. So do I want to build like the whole full enterprise super expensive stuff with lots of hardware and you know, licenses for software and all this kind of thing, and build a proper data warehouse? No, I don't really want to do that, because, well, you know, it's expensive and you don't really want to have server racks running at home. Even though, I mean, it's really fun. I was kind of always dreaming about having a little server rack at home, but it probably is a good idea when you think about it. But when you kind of try to do it, it's probably not as good as it sounds. I don't know. I still haven't got there anyway. So can I write something custom instead of creating a data warehouse and all these things? Well, I can do that, but that will suck as well, because the problem is, again, when you do that, you have to maintain all that, and there will be a lot of different APIs. The data will change, and you have to run this custom code all the time, and there will be a lot of moving parts, because you need to create all those kind of things that will read from files, that will write to files, that will parse things. It's a lot of moving parts. I mean, it will work for one-time job, but if you run it like regularly, it might be a little bit of a troublesome. So and that's a little bit of a sales pitch kind of thing, right? So flexible, portable, and open source. And that was basically what it was, because I was complaining about this to a friend of mine, and he was like, you know, have you tried this little new thing? It was some years ago, so back then it was relatively new, and he was like, yeah, have you tried this thing? It's really cool, and it's been open source some time ago, but now it's there is a community around it, and you can run it on locally, you can run it in the cloud, you can do it everywhere. And I was like, oh, that's really cool. And that was my kind of thought of the train of thoughts where I was like, okay, I can use this to solve my problem, and you know, I can do things about it. So now I want to talk to you about the way I built the whole system. So going from local, just running on my machine kind of thing, to a bit more advanced kind of thing. Before I do that, just say a few words about myself. So my name is Rustam. I live and work here in Oslo, Norway. I work for a consultancy company called Computos. I am also a Google developer expert for cloud, and I am as well a Java champion as well. So enough about myself. Let's go back to this solution or the thing that we have been talking about. So this was the kind of the Lambda architecture that I landed on first. So basically the whole thing started with me having a tiny little Raspberry Pi, those small tiny little computers sitting on my living room table and collecting all that data. So what I would do is to dump the data of the availability of the bicycles 4 times a year. Again, a year. So there is something, sorry about that, not a year, 4 times an hour. So 4 times an hour, so every 15 minutes, I would dump the availability of all the bicycle stops in the city and store them in a file. So I needed some kind of cron job. So basically, well, if you run Linux or whatever runs on the Raspberry Pi kind of operating system, so typically would end up running a cron job that would wake up every 15 minutes, dump the files from the API to a file system, and be happy about it. And then I would like to put those files into something useful. So now I would have to process those files, do something. So say, for example, if it's batch processing, something like Apache Spark or something like that, that will process all those files and do this thing, some magic with the data the way I wanted to, and put it into some kind of database. And then I can visualize it, using Jupyter notebooks or whatever. Things like that. But then I wanted to do another thing. The other thing I wanted to actually have a look at, what if I will be providing some of the data that I will be using will be provided to me with streams. So I wanted to have something that could handle streams as well. And then I was like, well, okay, I can do streams. I can do probably Apache Storm or something like that, put it in the same kind of database. And then I can do, so say, for example, the bike data is provided by batch right now. At some point, maybe they will be doing streaming, but then I wanted to have something that can do both. I didn't want to have like different tools. I wanted to make it as simple as possible. And what was that? So that was where this kind of tool came into my attention, and that was called Apache Beam. So this was a tool that was originally developed by Google, and it was open sourced quite some time ago. And the cool thing was that it would actually be able to process both batch and streaming. And by streaming, I also mean that, you can always think that at some point they will stream the availability data of the bikes and everything. But streams can be also much more fun. You can, for example, collect streams of weather data and put it into this data warehouse, and then you will know that, okay, if it's raining, then the availability will be probably more than when it's sunny, and things like that, right? So streams are really nice, and then it could actually handle both. So it could do both batch processing, files and stuff, and also streams. It would have the different APIs. So it would have SDK, so Java SDK. It also had, that was the original one, the first one that appeared. At some point, they also created a Python SDK, and also quite recently, they also announced the Go SDK as well. The other thing is that you write your model in Apache Beam, but then you can add different runners. So those different runners can process your data on different platforms and different places. So, for example, if you run it on your own laptop, you can use local runner. So this direct thing, it's called direct runner. In Beam language. Then you can also have another runners. For example, if you run it on the cloud. So in this case, this is Google Cloud, but then different clouds. It depends if they're gonna implement something like that. You can use their own cloud runners. So like Cloud Data Flow Runner, for instance, in this case. But then you can also run direct runners in the virtual machines in the cloud as well. So, it depends on the implementation and stuff. But also it would have different ways to communicate with Flink, Spark, Hadoop, and all those kind of things. And the cool thing is that you can also swap out the components much easier than if you would just write it yourself and hard code everything and just write some kind of custom code. Because the data might arrive with files, but it also can arrive in the form of a queue. So Kafka queue or some kind of pub sub queue or whatever. But then you can also store things in different buckets or platforms or file systems and things like that. So obviously you can use a regular file system. That's quite given, right? But then you can also put things into S3 buckets or Google Cloud Storage or Hadoop and everything. And then you will just need to switch a method that you use to read from those platforms, and it will just automatically just do that. That's really nice. Okay, so now I had this new version of the big picture, right? So this Raspberry Pi thing was now running cron job that would dump things to a file that I could process with Apache Beam at some point. So I was doing it not every time I would dump. So I would just collect a little bit of files. I would process them, put them in the database, and then just use it, because I did not have this kind of full pipeline, everything. It was not enough data to have it running continuously as well. So for now, I just had Raspberry Pi, and it would just run that thing. What happened was that that really worked for some time, but it kind of sucked as well, because I would have to handle a lot of things manually, and I had no redundancy whatsoever. So what happened was that the memory card on my Raspberry Pi died at some point, and then I lost, I think, some data that I had in between, like the things that I dumped, but the things that I did not dump until the card died. So I had to, I lost that. I couldn't really recover it or anything. So then I decided to, what if I put things, instead of having it on my desk and just have it kind of vulnerable there, because I can just it can just die, the electricity can go, and a lot of different things, connectivity and all these things. Maybe I can put it on the cloud. So then I did that, and then I moved the same kind of thing into the managed thing, and I did not the beauty of the whole thing. And I'm not really trying to kind of push a specific cloud. This pipeline, you could have just done in any cloud or any kind of data center thing that you wanted. In my case, I used a GCP for that, but you don't really have to. And so the managed version for that was that I would have another cloud function, so serverless kind of function that would wake up every 15 minutes, dump things to a storage, to a file system of some kind in the cloud, and then I would process it with the local version or managed version of Dataflow, or just Dataflow. It doesn't really matter, because we'll see why it doesn't really matter. And then I would dump it to a database, and I would visualize it with something. So that was really, really cool. And now I would like to talk about a little bit more. So now you have the idea of like my basic architecture of this thing. So now I would like to talk about a little bit of how you put things together with Apache Beam. So first I would like to mention this thing that I probably said already a few times, the word pipeline. And what is this thing? I mean, it's there is obviously a Wikipedia definition for that, but let's don't go there. I mean, let's keep it simple. Pipeline is a directed acyclical graph. Well, simpler. I don't know how much simpler that was, but then at least it was shorter. So it is a graph. So think of it as a conveyor belt. You have on one side, you have lots of pieces and bolts and screws and lights and bulbs and things, and you put all of that onto a conveyor belt. Lots of people standing, doing something with it, and at the other end of that conveyor belt, a shiny new car appears, right? So you do a lot of things, and at the end you will get some kind of other product or the other end. So this is the same idea as with the pipeline. Just the difference is that it's data, right? So you still put some kind of data on one end. There is a lot of transformations and things happening to it, and there will be some other kind of data on the other end that has more value for you. I mean, there must be a reason why you're doing this, right? And it has a direction, so directed graph. So you cannot just go back in time or back in this kind of transformations. And there is no cycle. So a cyclical graph, that means that, well, basically you would not have any loops. So you cannot just kind of cheat and go back. And so you'll have a loop there. So you will not be able to have that. So how do you do that? Apache Beam can be very, very advanced and very fancy, and there is a lot of cool features with it. But I want you to show, since I assume that most of you have not seen that thing before, I would like to start with something very, very simple. So extremely simple pipeline, just basic pipeline. And I would like to explain you how this works. Before I show you some code, and the code will be, well, obviously, as you might have guessed, will be Java. But before I do that, I want to show you the data source I wanted to do something about, right? So this was my availability data that I was dumping 4 times an hour. So I would have four files an hour, 24 hours a day for quite a few. I think I've been running it now for probably a bit more than 2 years now. So that's quite a lot of data, and all of that data looks like this. So you have a list of stations that has an ID, some kind of data about availability. So how many bikes are available, how many locks are available. So that means where you come with your bicycle, if you're able to put your bicycle into a vacant lock or not, because otherwise you won't be able to park your bicycle, right? And also some other data. So very simple stuff. And I wanted to go from this to something like this, to a table. And I also wanted to denormalize it, because if I go back again, you'll see that there is no date or updated date for each of this station objects. But at the bottom there, all the way at the bottom of this file, it would have a timestamp for all of them. And that really does not work when you want to do like when you want to do a data warehouse, or you want to do some kind of reporting on that. So now I had to denormalize things. I had to flatten structures. So for example, you see that it has nested structures like availability, and it has no timestamps and all these things. I wanted to flatten all that. So it would have ID, how many bikes are available, how many locks are available, some other metadata like overflow and blah, blah, but also a date for each row. And that was the very, very simple kind of pipeline that would be looking like this. You have input files, you read from those files, you do some kind of magic with it. You do with the text lines. You do something. I will explain it in a second, but something we call a Pardo. It stands for parallel do. I'll explain it more detail in a second. But for now, just something that you can do in parallel on many machines or threads. And then you have then you store it to a data warehouse, and then you store it to a table or something. So output would be a database table. As you can see there, the blue ones is the ones that actually doing transformations, and the white ones, the ones that has no fill, they are a P collection. So the different collections, so the different kind of states of the data, and then you apply some kind of transformation to it. Those square things, 3 square things in the middle, and then you go to next state and next state and next state. So if we go to some code, so the first step, remember 4 different steps, right? So the first step would be to define some basic options for your pipeline. So here I just used one option, but typically in the code I would have, I don't know, at least 10 or 15 or so. So things like input path for input files, output path, all those kind of things that you might think and might use in your pipeline will also all go into the options object or class. And you can also provide things like a description. You can give names to things. You can provide a default string. So if you do not provide that, what kind of value it should get by default, and all those kind of things. So in this case, I have a metadata input file, a getter for that. And I explain what it is. Well, it's a path to a file with availability data. And if there is nothing provided, this is what kind of path you should go for. And the cool thing, you can also provide like glob paths. So you can do like star .txt or things like that as well. So you don't have to provide just one file. You can just provide a list of things. Okay, so now you defined options. So for now, let's say we have just one option, but typically you would have more. Then you create your pipeline, and that's pretty much all the code you will have to do. So pipeline equals pipeline create options. Okay, that's step number 2 out of 4. So third one would be, that's where all the magic happens. That's all this. You remember the things that we had, this little white and blue boxes, and the blue boxes, they are this transformation. So this is what you do with this dot apply thing. So in this case, you see I created a pipeline, and then I apply a transformation which reads from files, and so creates reads data from files and creates some kind of objects. And then I do something about this data, and then I at the end I do dump it to some kind of output. So in this case, you can see that I'm doing just text files. So it says text.io.write, and then I say 2, and here I provide this options that I talked about earlier, right? So I just get this path where it should be written, and I can I don't have to hard code all that. Okay, so that's step number 3. And before we go to step number 4, I want to explain a little bit more about this Pardo thing that I mentioned earlier. So Pardo stands for parallel do. So and it's element-wise transformations, and it basically is something that can be processed in parallel on a lot of different machines or different threads independently of each other. And in my case, that would be, for example, reading things from a file and parsing the JSON file, JSON text. It's basically text, right? So parsing the text into Java objects and doing some transformations to the objects, that all can be done in parallel, right? Because one thread reads one file, another thread reads another file. They're totally independent from each other. They're from 2 different even times, and they can be processed in parallel, and they can be done on different machines, different threads, whatever. So that's a short version of what parallel do is. And in my case, as I told you, was this thing that extracting objects from JSON and doing some kind of transformations with it. As you can see here, I'm doing this new extract from JSON class. I create an object of that, and then just put it into Pardo, and and I do some magic with it. So the last step would be, when you created all your pipeline and defined everything, it would be to run it. And then you can do, that's the cool thing. And that's the thing I promised to explain why I thought it was so cool and so easy to move between things. Because you can run it on your machine, and you do it like, here is an example of where you do Maven compile, and then you provide some parameters. You say, well, I'm going to do a direct runner because, well, I'm running it on my machine. That's what runs on local machines. That's the runner that you're using. Then you also provide a path to a main class, and you do all these other things to it. But the thing is, if I want to run it on a cloud, and my cloud supports that, I can just, without doing any changes to my code, I can just change a few parameters in my Maven call or Maven command, and it will just run on cloud instead. I do need to add a little bit. On purpose, I'll go a few times back and forth between local machine and cloud. And you can see, so I changed the runner, so data flow runner instead of direct runner now. And I have also a bunch of other extra parameters there saying, like, well, where the buckets are and where the output is and which region I want to process all the data and where in the world I want it to be processed and things like that, right? But the thing is that I don't have to change any code at all, and my pipeline is still the same, and I have nothing. I do not have to even touch it. That's a really cool thing. And this is how the pipeline looked when I ran it for the first time on the cloud. So I did run all that, and I did process all that. I think it was like 8 months worth of data approximately. And I processed that in 20 minutes. And, I had around 17 machines that kind of woke up or brought to life, and they processed all that. And then they were just kind of graciously shut down. And the output was like this, right? And a little bit about how much data that was for like 7 or 8 months. There wasn't much. I mean, there was just like 36 megs of data, but it was 1.1 million rows in the database. So it was a little bit of data. It was not big data. It was not really nothing super serious, but it was fun. It was fun to play around, and I could process all that. I could create 1.1 million rows of historical data in 18 minutes without doing anything on my machine. If I would do it on my machine, it would take much longer. But then I wanted to do some more advanced things, and this is another cool feature I want to show off in Apache Beam. So as you've seen, probably you might have noticed that station metadata, availability data, does not contain any information about where that stop is. So just an ID. I have no idea where it is. I have to look up somewhere where that ID is and where it's geographically and what's it called and all the other things. And that is another API endpoint. So another point would be, it was called station metadata API or endpoint. That would provide me the same thing, all right, ID, but it will also provide me a title, an address, geographical coordinates for that thing, and all those things. And I wanted to put all that into, even denormalize my table even more. So I wanted to put all that into one big long row of data, so I can it will be easier for me to process all that. And so I ended up actually dumping not one file 4 times an hour, but actually ended up dumping 2 files 4 times an hour. And that I had to do because the stops would change and everything. So I could not just like look up a station whenever I needed. Maybe by the time I wanted to look it up, it would be gone, it will be moved, or things like that. And with historical data, I wanted to kind of keep the history of like together, right? So now I wanted to do something like this. So now we're even more denormalized thing. That's what you typically end up doing with a data warehouse, where you just put as much information as possible because storage is cheap and it's much easier to do that without having to run like joins and different things on the table. So that was my kind of version 2.0. Now I needed to do something more. So by that time I had another year worth of data. I also had, so I had another 600 megs actually of files that I needed to process. So that was 2019 already. Now we had 2 files per each dump, right? One for availability and one for metadata. But then I also needed to do something like this. As you can see in this picture, I have 2 pipelines starting. And at some point, I do a merge by ID. And then I put them together and I do some more magic with it and I dump it to the database. So that was my second version. That was a bit, I think it was almost a year later. So I had whole data for another 8-9 months for 2019 that I needed to process. And that was quite a bit of data. That was like 600 megs of data. So now it took me a little bit less time. So remember, last time it was 18 minutes. Now it's 14 minutes. But that was just because I had 160 machines instead of 16 machines. Processing that, so 10 times the size of number of machines. And then then I had much more data, and then I had actually almost 1 gigabyte, a little bit more than 1 gigabyte worth of data. So now we're getting somewhere close to a little bit of big data. It's not big data still, but it's getting there. And now we have 13 million rows of data, and all that been processed in nearly 14 minutes. That's really cool. And the funny thing is that I was running the whole thing in the cloud, and I did not think about one specific thing when you run on the cloud, which you should probably. It's the money, because I did not really think of how much it would cost. And then I got this thing on my console that it says, hey, you know what? You used actually 900% more than you've used previously. And then I got a little bit scared. So I was like, what is this thing? And I couldn't see the number of money, how much money that was, until pretty much day after. So I was a little bit concerned, and I was like, this 900%, that does not sound good. And then I saw the actual the price. I mean, the number that I have hidden behind the black box there. And that was just, 3.4 euros. So that's probably around the same, around $4 or something. I don't know, depending on the currency and exchange rates and stuff. But yeah, let's say it's $4 or so. And that was really, really fun. 160 machines for 15 minutes just costed me, a price of a coffee or something like that. That was really, really cool. So Yeah, and this is the price distribution. So mostly it was actually data flow, the managed version of Apache Beam running, but then it was a little bit also for storage because I was using it for storing files and all these things. And then it was like, then you're going to from this sad monkey, sad puppy that you've seen earlier to this amazed monkey kind of thing, right? You're just like, oh wow, this is really really cool. Yeah. So now we've seen one part of this, and we've seen the batch processing of this thing. But I also talked a little bit about the this thing of going from batch processing to a stream. I don't have that much time to talk about streams, and that was not really the point either. I wanted to give you a little bit of taste, but to kind of continue giving you a little bit of taste of this thing, I'll still mention a few things about streams as well. So basically, the idea of streams is where you go from having files, just stale files, to data that is coming in all the time. It's like a stream of water. You have a river or whatever that is flowing, right? So the problem with the stream is that you don't know when the data will arrive. So the data that for 8 o'clock in the morning about what happened at 8 o'clock in the morning might arrive at 8, but it also might arrive a little bit later, so at like 8:30. It can also arrive much later at like 2:30. And that sucks a bit. So you have to be able to handle that. And Apache Beam has a lot of methods to handle this kind of things. So it would, we've looked into the transformations a little bit. The thing that you use a lot with streams and stuff is the windowing, where you look at like a windows of data and you can separate those windows by time or by other things. We'll see that in a second. But you can also apply things like watermarks and triggers and stuff to your data. So say when I see a data that is about 8 o'clock in the morning, about things that happened at 8 o'clock in the morning, do this. So it would have like special triggers and things like that, for example. And you can also accumulate things. So you can do different kind of transformations, just convert one thing into another, or convert several things into one thing, or do a combination of all that. And then this is the windowing thing, and this is windowing based on time. So you just split it by, for example, an hour, and then you just put them into different windows and you look at that data. But then you can also do this accumulation thing where you look at the data and put them in the right buckets. Another thing that I mentioned a little bit earlier is that you can also do windowing depending on other things than time. So for example, sometimes you might want to do it depending on sessions and stuff like that, typically games and stuff like that. When you do that, you don't care when it happened, you just care more who did that, right? So you can do things like that as well. So it doesn't have to be time. A few cool features at the end before we finish off is that this windowing thing that I have mentioned already is very simple to do with a piece of code. So in Java, it would be something like you do apply. As we've seen earlier, we do all these kind of transformations and things with apply. But here you just do apply window. And then if you want to pick up a window, if you look at the data worth of 5 minutes and you want to do it every 1 minute, this is what you do. So you do a sliding window of 5 minutes. So the length of it is five minutes, but you do it every minute. So every minute you move that window and it will kind of still give you 5 minutes worth of data, which is cool. And it's very simple, right? You don't have to write all this fancy logic and comparing timestamps and all these things. Another thing is that you can also, you've probably seen me using this visualization thing in the cloud, and it's very, very pretty. But if you run it locally on your machine, it's not as pretty. Well, there is no visualization, basically. I did a little bit of digging, and I found a very simple way of dumping it to a to a file and visualizing it in at least some way. It's not super pretty, but it works because so I dump everything to a dot file and then I can do whatever I want with the dot file, because dot files are typical. You probably have seen dot files before. If not, just search for them. It's a kind of standard thing of representing graphs and things like that. So you can do a lot of things with it. So I did write a blog post that you can see the link there at the bottom of the slide, where I explain how you can do this thing on your local machine as well. So you don't have to upload it to a cloud to get it visualized, because sometimes it's really hard to see how things are going without visualizing the pipeline. Sometimes you do some errors that gives you different results than you expected, really, and you want to have that visualization. And then another thing is that you can actually move things from one output to another with just a simple thing. So here I was dumping things to a file. Now I replace those two lines with two different lines, and now I'm dumping things to a database. So in this case, it's a BigQuery, which is a data warehouse kind of database thing. But you can do different things depending on what is supported and things. You can also dump things to another kind of database, or kind of move your stream of data to something else. Like in this case, I dumped it to another database that gave me a visualization just out of the box, where I could see things on the map just right out of the box, just with 3 clicks. And also open source database called ArangoDB. Yeah, and then you can, at the end, when you put all that, you will see that the thing that we've seen in the beginning of this talk, where you can do trends, you can do analytics, you can write big, complicated queries like this one, returning you availability depending on the day, time of the day, time of the week, all those kind of things. And you can combine it with, I don't know, weather and vacations and things like that. And this is really cool. And then we're kind of a little bit back to this amazed monkey thing. So it was kind of a little bit of my feeling as well, because I was like, whoa, this is too simple, this is too easy. And that's kind of what it was. And it's free and it's open source and everything. A few warnings at the end is that your data will change and your data sources will change. And still, at the end, it's a kind of an ATL job. So you'll need to do some kind of adjustments and things like that. It's not just silver bullet that's going to solve all your problems, but it will work. One last link. All of the code that I showed you and I've talked about is open source and it's online on GitHub. So use this link to have a look, and also feel free to ping me on Twitter. That's my handle there, and also my email down there, and my blog as well. So feel free to ping me, to ask me any questions, and I'll be happy to help you or guide you or direct you in the right direction anyway. Thank you very much for having me, and I really hope I'll get to see you next year, and maybe even in person. Thank you very much.
Thank you, Rustam. Congratulations. This was a great session because it shows a real problem, the architecture and tools to solve it. And the best is the GitHub repo.
It is, and that was the kind of the idea, is to encourage people to solve their problems as well with a little bit of code. You can do a lot of magic.
That's perfect. Okay, guys, this is the time of questions. If you prefer in Spanish, I can translate that.
My Spanish is not very good. I can understand a little bit, but probably not questions. So thank you. If you can translate that, that would be great.
Yeah, no problem. It's my job. Okay. Bueno, if there are no questions, I am sure after watching the video several times, the public will contact you by Twitter or by email, Rustam.
Ping me and I'll be happy to help you. It's really nice to be here. It's been great. Thank you very much for having me.
Thank you very much for the talk. We hope to have you one day in Lima, Peru in person. Thank you for your support.
I would really love to do that.
Okay. Take care, Rustam. See you in the next
Take
next
care.
conference.
See you. Bye-bye.
Bye-bye.